One fine morning at Galileo's cave.
I've always been very curious about suction pumps. Today seems like a good day to figure it out. I wonder how much water this suction pump can take out of this well. Let's find out. First trial. It seems that the suction pump was only able to take out 34 feet of water. Let's try it again. Trial number 2. 34 feet again. Seems like there's a trend. Final trial. Only 34 feet. What could this mean? 3 trials, each one only 34 feet. I wonder what this could mean. I hypothesize that nature must abhor vacuums.
Graduation day.
Young Torricelli. Yes, Master Galileo. Torricelli, you have now graduated from my School of Science. Thank you, Master. Fare thee well, Torricelli. Go out into the world of science and make your own hypotheses. It is now your turn to account for the phenomena in our vast universe. Thank you, Master. I think it's time to once again revisit the problem of the suction pumps. Let's try this one more time. Only 34 feet. But I don't think that nature abhors vacuums. I think that the answer is much more complex. After careful consideration, I have devised a new hypothesis. I think that the Earth must be surrounded by a sea of air. By reason of this weight, the sea of air exerts pressure upon the surface below, and this pressure upon the surface of the well forces water up the pump barrel when the piston is raised. The maximum length is 34 feet, and this reflects simply the total pressure of the atmosphere upon the surface of the well.
Back at Galileo's cave.
I think it's time that I test my hypothesis a little more. I think this time I should use mercury, but that will call for some protective gear. Now I think that I'm prepared to deal with the poisonous qualities of mercury. Now, when we perform this experiment, we must take into account the difference in weight between water and mercury. So, if my hypothesis is correct, the pump should only be able to draw out about 2.5 feet of mercury from the well. Let's perform the experiment. Trial number 1. Pump malfunction, pump malfunction. Ah, containment alert, red alert, red alert. Beep, beep, beep. Thank God for containment personnel. Alright, now that I've reconfigured the pumping system, let's try this again. Trial 1. Just about 2.5 feet, as I suspected. Let's try this again, just to make sure. Trial 2. 2.5 feet, right again. It looks like my hypothesis has been further corroborated by new evidence. Period. That means you too, you know. Don't tell me you're still afraid of the light. Sorry, Pascal. No, Pascal, I still don't like the light. Alright, Perrier, I think it's time that we further test Torricelli's hypothesis. This time, we need to test the effects of altitude on air pressure. If Torricelli's hypothesis was correct, the air pressure at the top of Mount Puy-de-Dôme should be less than at the base. So, Perrier, I will take one suction pump to the top of Mount Puy-de-Dôme, where I will conduct my own trials, and I'll perform 1, 2, maybe even 3 trials. Now you, Perrier, will stay at the bottom of Mount Puy-de-Dôme to make sure that the suction pump remains constant and can take up the same amount of water with each trial, and there's no unforeseen anomaly in the atmosphere while I'm conducting my research. Alright, fairly well, Perrier. Make sure that the suction pump remains consistent and there are no atmospheric anomalies while I'm performing my tests. Goodbye again, Perrier.
At the base of Mount Puy-de-Dôme.
Dun da da da! It appears that the column of mercury in my barometer is much shorter than it should be at the bottom of the mountain. I wonder how things are going with Perrier. Hypothetically, his column of mercury should be much larger due to the increased atmospheric pressure.
After experimentation.
So, Perrier, what results did you see? Well, Pascal, it looked to me that the column of mercury in my barometer was just as long as we had foreseen. What did you experience, Pascal? Well, Perrier, the length of the column of mercury was just as large as I had expected as well. It seems that Torricelli's hypothesis is accurate again, and this new evidence once again further corroborates that hypothesis.
Torricelli's theory was applied to the use of barometers in measuring pressure. This led to the further expansion of experimentation, like Pascal and Perrier, for hypothesizing about atmospheric pressures at different altitudes.